Okay, here's a good question. Let's have a look. A spring stretches by 2 centimeters. Okay, that's important. So let me just put that in under. I'm going to highlight that. When a force is added. Okay, so we've got a spring. I'm stretching it. I've got a force. The spring constant is 60 newtons per meter. Okay, spring constant, newtons per meter, 60. Alright, calculate the energy transferred to the spring when it is stretched. Okay, I like to underline the key points in the question because what's important. Okay, sometimes you can cut out a lot of distracting kind of information. Okay, so understand the context first of all. This is a multiple choice. Don't start looking at the numbers and guessing. You have to work this out. Okay, you can look at some numbers and go, oh, 260, oh yeah, it's going to be 2 times 60 or something, 120 joules, and you're going to choose C or something like that. If you're guessing, you might be right. Okay, but how do you know? You don't want to just guess. You're in an exam. It's a physics exam. You're supposed to be proving you can do it. Okay, so let's just do this. Okay, it's only worth 1 mark, but it's a mark that a lot of students will get wrong because guarantee quite a lot of students will look at this and just go, yeah, it'll be that one. Okay, no, work it out. Okay, right, so it's a calculation question, there's numbers in it. Okay, there are more than just the clues in the question up here. Okay, there's things like the units. I've got centimetre, well, that's a distance. Okay, force, fair enough. I've got newtons per metre, that's a huge clue. Okay, and I've got down here, every single answer is in joules. Okay, and that relates to the energy transferred up here. So what we're going to use here to get this answer, well, we're going to go QUENS, aren't we? Okay, QUENS, we're going to use this process to work it out. What quantities do I know from the question? The spring stretching by 2 centimeters. If you remember, that's an extension. Okay. If you remember, it helps you just write last, so you can just go X equals 2.0 centimeters. Identify the quantity, give it a label, include the units up here. I've got a force, okay, mentioned. Okay, so I might want to think about that. That might come into play, but I'm going to write it up here. But there's no value there. Okay, but I remember that forces are measured in newtons. I've got a spring constant, 60 newtons per meter. Okay, spring constant. Constants generally have the letter K. That's handy because I can write less. I've got X, I've got K, and now it's talking about calculating the energy, and that's going to be in joules because that's what we're looking for, joules. Okay, so I've got 2 unknowns here. I've got X, I've got K. Before I do anything else, I'm going to just check my units. Okay, U for units. Centimeters, I don't like those. Newtons, fair enough. K is newtons meters, that's good. Joules, that's fine. I've got joules. I have to have things in newtons and meters to have to be consistent. Okay, it's the centimeters that stands out to me. That needs to be in meters because we've got meters here. Okay, so I'm going to rewrite this. X is 2 centimeters. There are 100 centimeters in the meter. That's 2 zeros in the 100. So I need to move my decimal place twice. Okay, I need to put an extra 0 in here, and my decimal place is going to be there, so it's going to be 0.02 meters. I could, if I remember, just go, I've got 2 centimeters. To convert that to meters, I know that centimeters basically is 10 times 10 to the minus 2. So if you're good with your standard form, you might want to just do that. If you want to just move a decimal place and write it like that, that's absolutely fine. I know that if this was a long answer, I'd have a mark by now. I'm taking a bit of time on this, even though it's only worth 1 mark, because I want to get it right. Okay, now I need to use the right equation. I've got X, I've got K, I've got E. I'm thinking the F is potentially not needed, but we'll see. Let's have a look. Let's have a look at the old equation sheet. What can I find? Okay, I'm going down here, I'm looking for K. The K is the letter that doesn't fit a lot of these. And there we go, there are two equations to do with springs. Okay, I've got extension in my question, I've got spring constant, and it does mention force, but I haven't got a value for that. Let's see what my other alternative is. I want one with energy in it really. Energy transferred and stretching, half spring constant extension. That's the fella. Okay, E equals half kx squared. This seems like a lot of work for multiple choice. Okay, that's good because it means I know a lot of students are going to give up on this and not be able to do it. Okay, so I'm going to keep going. I want to get this mark. So energy transferred equals half. Well, I can rewrite that as 0.5. It's a bit easy on, I don't like fractions. Let's get rid of it. Let's turn it to 0.5. Do I know K? Yes, I do. So I'm multiplying by 60. Do I know X? Yes, I do. But careful, X is squared. So I'm going to put that in brackets and square it. And I've already forgotten to put my 0.02 in. So I'm going to, excuse me, and do this. I'm going to still put it in brackets and square it though. Okay, now no one likes a square, so let's solve that bit first. We can rewrite this and make it a little bit easier for myself. And also I know 0.5 times 60 is 30, so I'm going to just make this a bit easier. I'm going to say 30 times, okay, and what is 0.02 squared? Let's do this separately rather than try and tap it all in one go. 0.02 squared gives me 0.0004. Let's multiply my 0.0004 with 30, and I get 0.012 joules. That's a very small number. Let's have a look to see if it exists in my options. Oh, well, there it is, A. So no, it isn't C, it isn't 2 times 60. Okay, don't jump to conclusions, work it out. Okay, if you would have said 120 joules because you're being lazy, well, you got it wrong. Okay, I've got it right. Thank you, QUENS.